This video is on topic 9, graphing quadratics without a calculator. So we're going to talk about 3 different forms of quadratic equations. We've seen standard form before when we were talking about the quadratic formula and when we would factor things out. So standard form is our y equals ax squared plus bx plus c. Intercept form is our factored form. So we've done factoring before, we just didn't call it this intercept form. Lastly is vertex form. In vertex form, we're going to complete the square in order to take a standard form equation to get to the vertex form equation. One thing that I want to point out is that all 3 of these have only one of the coefficients in common, and that is a. So notice how all of these have a, but standard form has a b and a c, intercept has p and q, and vertex form has h and k. So all different variables that represent other things, but the a is the same. So these 3 forms represent the same quadratic in 3 different ways. So you can write one quadratic equation 3 different versions, but it would be the same graph, just a different kind of manipulation. Because a is the thing that's in common with all of these versions of quadratics, it's a super important number. A is the leading coefficient. If a is greater than 0, if it's positive, then that means that our quadratic function will open upward. So it would be a parabola that looks like a U. If a is less than 0 or negative, it's going to open downward. So it would be a parabola that's down, like sort of an N, I guess. And just like with our absolute value equations, if a is greater than 1, then it's been stretched, so it's kind of skinnier. And if a is less than 1, it's been compressed, so it would be a little bit shorter and fatter. So topic 9a and 9d, we're going to find the vertex of this quadratic, then write the function in both intercept and vertex forms. We're going to use this equation that's up top, x equals negative b over 2a, to find our vertex. So just like with our quadratic formula, we're going to take negative 6 over 2 times 3. So the same kind of process from the quadratic formula, and this actually comes from the quadratic formula right here. So negative 6 over 2 times 3 is going to simplify to be a negative 1. Now we're going to take that and plug negative 1 in for x in our equation. So y equals 3 times all of this, and when we simplify, we're going to get negative 12. So that means our vertex is negative 1, negative 12. The next thing we want to do is write this in intercept and vertex form. So I'm going to start with the vertex form because I think it's kind of harder. So what we're going to do is actually complete the square just like we did in our last unit. The difference is that we're not going to actually solve this quadratic, so we're going to keep the y where it is. But I do want to move that constant to the other side. So I'm going to start by adding 9 to both sides from our original equation. Now remember, with completing the square, the thing that everybody always forgets is that we can't have that coefficient out front. So what we're going to have to do is factor it out. So I've factored it out. It's just sitting out front, not changing anything. And now what we're going to do is add our b over 2 squared. So this is where it gets funky when there's a number out front, because we're not just going to divide it on both sides, otherwise we'd have fractions, it'd be a whole thing. What we're going to do is add our b over 2 squared. So 2 divided by 2 is going to be 1, squared is 1. The issue is I'm not just adding 1 on both sides, I'm technically adding this 3 times 1 on both sides. So over here, I'm adding 3. This is the thing that everybody forgets. This is the weirdest part about completing the square. I cannot stress it enough. If there is a coefficient out front, it is being multiplied by that thing that you added inside. So when you add it to both sides, you're adding 3 times that. So now I'm going to combine my like terms over here, and I'm going to factor the right half to be x plus 1 squared. And I'm going to subtract 12 on both sides, so we get 3 times x plus 1 squared minus 12. Notice that that negative 1, that h term there, and the negative 12 is our k term. So h and k should be the same values we got in our vertex earlier. Lastly, we want to get this in intercept form, so we need to factor it. We're going to factor out that GCF from the original equation, so 3 times the quantity of x squared plus 2x minus 3. And now I can factor this even further. 2 things that multiply to be negative 3 and add to be positive 2 are going to be x plus 3 and x minus 1. So this is our intercept form of our quadratic. 3 different forms. Standard was the given one. We've got vertex form here, and we've got intercept form here. All the same quadratic. Moving on to topics 9a, b, c, we're going to graph without a calculator. So if we are given this equation right here, we're going to start with our vertex. That's usually the easiest thing to start with. So x equals negative b over 2a. I'm going to plug in my values and simplify to get 8 divided by 4 is 2. Next, we want to plug 2 back into the original equation for x so that we can find the y that goes with it. We're going to get y equals negative 2. So we now have a point that we can put on the graph, 2, negative 2. And that's the vertex. And if we think about this parabola that we're given, the equation, a is positive 2. So that means I know this parabola is going to be upward facing. So this vertex is the bottom, that minimum value of the parabola. The next step is going to be to fill out a table of x and y values. So we already have the vertex, 2, negative 2, and I always put that in the middle because parabolas are symmetric. So I'm going to choose some points that are right below our vertex, or to the left of our vertex, I should say, and right to the right of our vertex, and just plug in those x values. So when I plug 0 into my equation here, 0 minus 0 plus 6, we're going to get a 6 out. When I plug 1 into my equation for x, I'm going to get 0. And let's keep going. Plug in 3 and 4. Hopefully you noticed that the 2 right next to the vertex and the 2 that were 2 away from the vertex gave us the same y values. That's because parabolas are symmetric. So these points should be symmetric. They should sort of line up around our vertex. And we connect the dots, and there is our pretty parabola, our U-shape. Notice how the 2 being in front makes it skinnier. It's stretched away from our parent function. It's taller. Now I want you to try number 2 here. So first step is to find the vertex. Then you plug in the x value and find y. And then you want to find some other points. So give it a shot. So this is what my parabola looks like. Upside down. And we've got this table of values here. The vertex at negative 2, 5. Now on to the back. For transformations in vertex form, think back to our absolute value stuff when we had y equals a times x minus h in absolute values plus k. Same kind of stuff. It's just a different parent function. Our absolute value was the v-shape. Our parabolas are going to be u-shape. That's literally the only difference. So our negative in front can reflect over the x-axis. Our a value can do 2 different things. If it's less than 1, it can compress our function. And if it's greater than 1, it stretches our function. H sort of behaves funky. It can shift our function left to right, and it's going to be left if you see x plus something, and it's going to be right if you see x minus something. So it's kind of that weird backwards thing. And lastly, k. K moves up or down, and it's up with a plus, down with a minus. So that one behaves sort of what you'd expect. So let's actually put it into motion. Our parent function is y equals x squared. It's going to be that parabola that sits on 0, 0. It sort of has an up 1 over 1 and then up 4 over 2 pattern because of the squared business. Don't worry too much about that. But that's our sort of pattern that goes on. So this graph here, we have a bunch of transformations that are occurring. So 3 transformations. We've got a reflection because there's a negative. We're moving left 3 because of that x plus 3, and up 2 because of the plus 2. So our new vertex is going to be left 3 and up 2 from that original parent function. So here it is. Now it's reflected, so it's going to be facing downward, but the steepness hasn't changed. So our normal steepness of down and over 1 and 1, but because it's squared, it's going to be going over 2 and down 4. So over 2, down 4, over 2, down 4. Think about the fact that it's x squared. It's not absolute value, so it's not going to be like a normal linear slope. It's getting that squared slope. Another way that you can always be sort of sure about what your points are is to plug in some table of values. Once you find the vertex, plug in some points before it and after it into your equation to find the y values. Alright, I want you to try this next problem over here with that compression and the reflection and this shifts, and then come back in a second and check your answer. And as you check your answer, I want to just point out one thing here. I want to plug in numbers that are going to make even things so that when that 1/2 happens, it's going to be easy to work with. You can plug in any numbers, but I'm going to be really specific about the numbers I plug in. So here is our parabola. It's compressed, so it's a little bit fatter looking. It's upside down, and that 1/2 definitely makes it harder to graph, so the table of values is probably pretty necessary. All right, these last 3 problems, topic 9E, we're going to write an equation. Now notice how it doesn't say what kind of equation. We could use either intercept form, standard form, or a vertex form, whichever one makes the most sense. So for this problem here, number 1, we're given the vertex and a random point. So if I'm given the vertex, I'm going to start with vertex form. Y equals A times x minus h. H is going to be your x value minus k, or plus k, but negative 10 in this case. So we've already got the bones of our vertex form. The reason that this point here is important is because we don't know what A is. A changes the steepness of it. So we're going to have to plug in the y value of 54 and the x value of negative 3 and solve for our A value. So A is going to be equal to 4. So that means our vertex form equation is y equals 4 times x minus 1 squared minus 10. Something that a lot of people forget is the squared, because we're so used to not having to really deal with it, but that is super important in vertex form. Next up, problem 2. We're given x-intercepts, so we're going to use the intercept version. Now remember, our zeros, our x-intercepts, are the opposite of our factors. So if x equals negative 2, then x plus 2 is a factor. And if x equals positive 2, then x minus 2 is another factor. But we've got to remember y equals a times all of those things, because a changes the steepness, the slope of our function. And we're going to use this point just like the last one. Plug in y of 8 and plug in x of negative 4 everywhere you see an x, and solve for your a. So a equals 2/3, which means our function is y equals 2/3 times x plus 2 times x minus 2. And that would be the intercept version of this equation. Lastly, number 3. So I always like to look at the vertex first, but the vertex here is going to be like 1/2 4, maybe, but it's sort of questionable, so we can't really rely on that. But there are other points that are pretty solid points. I've got these 2 x-intercepts, and then I've got this random point on the side here. So my x-intercept is x equals negative 2 and x equals positive 3. So that means x plus 2 and x minus 3 are some intercepts. We've got y equals a in front of it. Then we're going to use this random point, negative 1, 2. So I'm going to plug in the y value and the x value, and then we solve, just like the last ones. So I got a equals negative 1/2, which means y equals negative 1/2 times x plus 2 times x minus 3 is our final answer here.